Okay, so for this illustration, I am doing number 9 from your textbook, and they go ahead and give you the note on the alternate. So guys, this is going to be a sigma unknown scenario because they do not give you sigma, they give you the sample standard deviation. So in this case, I'm going to go ahead and draw my curve, and because the alternate says greater than 10, this is going to be an upper tail test. So I'm going to shade that part of the tail. Alpha is going to be 0.05, I know that's that area. And let's go ahead and extract some more data. The sample size is only 10, but we can still do normal. And it looks like the sample mean turned out to be, in this case, it was 12. And the sample standard deviation, notice that is equal to 3. So if we wanted to get our critical value, what do we need? We need the degrees of freedom, which in this case is going to be 9 because it's 10 minus 1, paired up with alpha. This is a one-tailed test, so I'm down here in my table, I pasted it in. So here's alpha, 0.05. And so I'm looking for where it says degree of freedom of 9. So if I go right down there, you see the value, it's going to be 1.833. I'm going to put that right there. That's my checkpoint. Now, to get my test stat, it's just basically using your sample. So your sample mean was 12 minus 10, which is the hypothesized mean. The sample standard deviation was 3, divided that by the square root of 10. So in this case, we are going to get a test stat that's right at about 2.11. That's definitely in a rejection area. So we're going to basically, our conclusion is going to be reject the null just looking at that. Now, of course, if you wanted to also get a p-value using this value, I'd go back down to my table here where it says 9. And it looks like 2.11 falls between this 1.833 and this 2.262. So using the one-tailed test, that's going to be between 0.025 and 0.05. That's going to be our range of p-values. And that's still less than or equal to alpha. So that's true. So we definitely get a fail. I'm sorry, we get a reject the null criteria because this is true and this is true. And so the sample is definitely supporting the alternate hypothesis in this case.